Okay, so the third type is that they say find 2 points on the line to be graphed and enter the coordinates in the boxes below. But you look at the equation, you've got both variables there. You've got two variables, so you think about, okay, how do I graph this? You can find any 2 points, and what you'll need to do is think about this really in terms of making a table. And I think if you go to tutor mode, they're going to explain it hopefully pretty well. I guess the idea is that I'm thinking about plugging in something for x, see what I get for y, and it's kind of can be done in a table. See what they say. Okay, so they're plugging in something for y. It's kind of not the conventional way to do this, but it can still work. If I plugged in 0 for y and I solved for x, what I end up with is negative 0 equals y, or equals x, or 0 equals negative x. I'd divide both sides by negative 1. I'd still have 0 for the x value. So 0, 0 is going to be one of the values that you're going to get. Okay. Now they're saying plug in if x is 0, see what you get for y. This is really not the way that I would do this, but we'll kind of follow what they're saying. If I plug in 0 for x, I'm going to get 0 again for y. So we already kind of know that that's one of the points. So we're not done. We have to find another point besides 0, 0. So I think what they're saying is here, find another distinct point. If I were to plug in something like 1 for x, I'd end up with y equals negative 1. And that would give me my y value. So just pick something, plug it in for x, work it out, see what you get for y, and then that gives you another point for x and y. So that's it. Okay. Let's see. And they gave 0, 0, 7, negative 7. Really, it could be any 2 points that satisfy the equation. Alright, we'll go to the next problem. I'm going to try to find another one of similar type. There we go. Okay, similar type. Find 2 points. We've got an x and a y. So think about if I were to plug in 0 for x. I plug in 0 times 9/5, negative 9/5 is 0 here. Take away 5. I'd end up with a minus 5 for my y value. What else could we do? Well, we could actually plug in something that would come out nicely. Because 5 is a denominator here, what would happen if I plugged in negative 5 for x? Well, if I plugged in negative 5, negative 5 and 5 reduce, and you end up with negative 1 times negative 9 is 9. Take away 5 would be 4. This was just my choice in terms of plugging in, but you really can plug in anything you want that's going to work out to a true value for y once you plug in something for x. So these 2 points should satisfy what they're looking for. Okay. One more example. Find 2 points on the line to be graphed and enter the coordinates in the box below. Again, we have an x and a y here. So if I plugged in, say, 0 for x, I'd have to work it out. Well, there's not much to work out, I guess. But if I plug in 0 for x, negative 8 times 0, that goes away. Y would equal negative 9. So that's one of the points. I can go for intercepts. They don't specify, though. So if I wanted to plug in 1 here, plug in 1 for x. Negative 8 times 1 is negative 8. And if I add 8 to both sides, imagine doing that. You'd be adding 8 to negative 9. we get negative 1 for y. So it looks like a pretty steep line there, but that should be it.